Now let's solve a problem of JEE Advanced 2024. Suppose we have a block of mass m. This block is moving with velocity v, which is given by a omega by 2. Here we have another system of two mass. And the mass is connected by a spring. This is a reference point, xy plane, and we have given this as 2 and 3. This system is oscillating like this, but this is center of mass. This is x0, and the displacement of this mass or position is given by x2 is equal to x0 plus d minus a sine omega t, and this block is given by x3 is equal to x0 minus d minus a sine omega t. Not everything has been usable. That means this d is because of its natural length, and this x naught is because of position of center of mass with respect to origin. What happened? This block is moving here, and after some time it collides with this block, and question says that the collision is elastically. The time of collision is given by t equals to pi by 2 omega. Now question says that after collision what will be the value of 4b square upon a square, where b is the amplitude of oscillation of the system after collision and a is the amplitude of oscillation of the system before collision. This block is oscillating about this reference point with an amplitude a like this, and at the same time this is also oscillating like this, and this is moving here from here, and this collides here. And after collision what will happen? These two blocks will started to move here. At the same time it will collide, try to oscillate like this. So the system will be like this, the moving and oscillating at the same time, and the amplitude of oscillation will be given by b. And the question says that what will be the value of 4b square upon a square. So to solve this problem we will use conservation of linear momentum and conservation of energy rule. Then we can solve this problem. So before that let's understand how we can do that. Here b is the amplitude of oscillation after the collision or process. So when v will arrive, b will arrive. So when that block is moved through a distance b, and this is also moved through a distance b. Now this has been moved through a maximum distance. That means the compression of the spring is maximum. So we have previously proved that at maximum compression both the block will move with the same velocity. So we will apply the same rule, and again we will use the conservation of linear momentum. So now, and question says that this collision between this and this two block is elastic. That means the velocity of these two blocks will interchange. You may have heard that if the collision is between two same block is happening elastically, then their velocities gets interchanged. Before that we will have to find the value of its velocity, that means v3. So now we will differentiate this a. Now differentiating this we will got v3 is equal to minus a omega cos omega t, because these two are constant, so only differentiation will happening by this. Now put the value of t. So v3 at time t equals to minus omega times pi by 2 omega. That means minus a omega cos of pi by 2. So we know that value of this is 0 because cos pi by 2 is 0. That means V3 is equal to 0. That means when the collision is happening, that block is at rest, and at the same time this block is also rest, because if we put the value here. So in the simple harmonic motion, when the block is get rest, when spring is maximum elongated. So here we will see this block is oscillating about this, and when the expansion of the spring becomes a, then this block eventually comes to rest. At the same phenomena will happening here also. So at this point, when the spring is when the blocks are at rest, so the total elongation of the spring will be what? That will be 2a, because it has also been moved through a distance a, and it has also been moved through a distance a. So the total initial elongation will be 2a. Now we have got enough information. So now final situation will be what? Our final situation will be just after collision. This block is moving with velocity v, because velocities have been interchanged, and this block is at rest, and the expansion of the spring is 2a. After some time, what will happen? Spring have been compressed through a distance 2b, and at that instant both the blocks will move with the same velocity. Let's that velocity is u. Here it is moving with velocity u, here also it is moving with velocity u, and the compression of the spring is 2b. Now, because forces acting on the system are equal and opposite, and there is no external force acting on it, so the momentum of the system of this will be always conserved. Now we will apply conservation of linear momentum. So first we will see from here, its mass is m, that means mv equals to its momentum m plus m times u, and similarly from here we will get u is equal to v by 2, equation first. Now we will apply the conservation of energy associated with this particle and this spring. That means half m v square plus half k 2a square. This is the initial energy associated with this block and spring. And what will be the final energy? Finally, this block is moving with velocity u, this is moving with velocity u, and a spring has been compressed through a length 2b. That will be equal to half m plus m u square plus half k 2b square. Now see here, what is this? This is half mv square, that means energy associated with this block, and this is half k 2a square, because the initially spring was expanded through a length 2a. This is the final kinetic energy of the system, half 2m plus m times u square, because both the spring is moving with the same velocity, and this is half k times 2b square, because now the spring has been compressed through a length 2b. Now we will have to solve this equation. Before that, let's erase this. What is this? This says that half m v square plus half k 2a square is equal to half 2m u square plus half k 2b square. Let's put that here and let's transfer this here. And then we will take half k common. Now here m v square by 2, this is, and if we have moved it here, minus m u square, because this 2 get cancelled, and now we will take half k common. Half k here, what will happen? 4b square minus 4a square. Now we will put the value of u here. What was the value of u? U was v by 2. Now m v square by 2 minus m v by 2 whole square is equal to half k 4b square minus 4a square. It will comes out to be, after simplifying this, that will be half b square by 4, that is 4k by 2 b square minus a square. Now see, once again, see, if two blocks are connected, here m1, m2 and its k, the frequency of angular frequency of oscillation of this block will be given by omega is equal to root k times m1 plus m2 by m1 m2, right? This is the frequency of oscillation of this system, but in our case m1 and m2 was equal, so if we put that value, that will comes out to be k times 2m by m square, that means 2k by m. So the value of omega are 2k by m. Let's write it here, 2k by m. Now put that value here, m by 4, what is this? A omega by 2 whole square is equal to 4k by 2 b square minus a square. Just simplifying this, and again put the, let's write it here, m by 4 a square omega square by 4 is equal to 4k by 2 b square minus a square. Put the value of omega from here to here, so m by 16 a square, omega value of 2k by m is equal to 4k by 2 b square minus a square. Now this k and this k will cancel out, this m and this m cancel out, and from here we will divide it by 2 and this 2 will get cancelled out. So now final will be have a square by 16 is equal to b square minus a square. Put that value here, a square is equal to 16 b square minus 16 a square. Now the value of a square is equal to 16 b square from here. So 17b square is equal to 17a square is equal to 16b square. So 17 by 16 is equal to b square by a square. What we have to find out? 4b square by a square. That means 4 times 17 by 16, and that will comes out to be 4 4 16 4.25 4. So 4b square by a square is equal to 4.25. This is the solution. We have used the same concept which we have explained it earlier. Okay, thank you. Bye.